My name's Keith Lafaso. I'm been with WEI. Will be 2 years in November 1st of this year. Kind of the goal was to kind of grow the actual cloud practice within WEI. So again, focusing on AWS and GCP, but this slide also talks to Azure. So we do deliver a number of different services around strategy, execution, operational support, and enablement. So like I said, we'll do roadmaps, strategies, planning, designs, workshops, strategy-wise, technology, assessments. We do cloud transformation, disaster backup. So a number of different areas across the board with cloud. Also, a lot of hybrid designs, folks that are not still looking to migrate over to the cloud. So we'll partake in some of those. So one of the big questions is, you have your own data center, you have your own environment, but who is responsible for cloud security? So a lot of times, if it's a managed service provider, you have different levels of platform as a service, software as a service, infrastructure as a service. So it all kind of falls down who's responsible. So I'll talk about the shared responsibility model within AWS, but I thought this was quite interesting that, 99% of the cloud security failures would be the customer's fault. And this isn't from AWS. This is just from independent research firm. I didn't actually note that in here, but a lot of times it's just misconfiguration. So, it's either fat fingering or just kind of, manually intervention rather than infrastructure as code or automation or not really truly understanding the environment and making some change. Like, more recently, like it was more along the lines of open S3 buckets that were there to do, for general consumption, but essentially left it wide open for some social security numbers or other personal information that shouldn't be shared to the public. And then it's like, how do I get started? So, what are some of the security best practices? Performing asset inventory in AWS, a lot of times it's a lot different when you have your physical infrastructure on site. So, I get a lot of questions around, how is that possible in AWS, especially when I have my VMs or EC2 instances, and I can get a hold of those, but also get an inventory of, maybe other areas where developers are using serverless environments where things are coming up and down with Lambda or, EKS, which is the Elastic Kubernetes Service or Fargate. And then, how do I patch and report? Some of the tools might be different within the AWS. So whether or not you extend that across into your from your on-prem environment, you can use some of those tools depending on the operating system and level. But there are some tools, and I won't really talk about patching today, but I'll just talk about a high level. Which AWS services should I use? Specifically, not just around my application, but what should I use for security? And then we'll talk a little bit about, at the tail end, I'll talk about Palo Alto's Prisma Access and how you can use that tool in your environment. And then, if my resources are configured securely and preventing misconfigurations that can lead to security vulnerabilities and exposure that you see in the news, or just like I talked about earlier, those are the common ones. Sometimes a lot of those don't get disclosed. And then this is another one that over the years I've had key customer ask, what security best practices should I follow? Identify resources non-compliant and take an action plan. And then the last one's kind of important, and I'll discuss that too, but increasing automation and reducing manual process. Because a lot of times, getting started, getting to learn AWS, yeah, manual processes are fine, just going about it. But say if you have a couple individuals that want to fire up a EC2 instance, that's okay. But if you start like batching or saying you want to grow or expand to 50, 100, so that's when automation will help and kind of plan that environment so there's consistency throughout, no differences, and then the ability to if it doesn't come out right, you can destroy it and then come back up with another one using Terraform or CloudFormation. Strong cloud governance is at the heart of every successful cloud journey. So that is very true. In governance, a lot of people think, well, is that also cost management? Yeah. So, without having kind of governance over your cloud environment, it's not gonna be good. So I could say, well, these are some of the security findings that I might find in there's a tool within AWS called Trusted Advisor. Those are a high level, but those things you can, change, make those changes, but then they might appear later in the future because maybe individuals turn those back on because there's incorrect identity and access management IAM permissions to those roles, things like that. So, it does start out with that good foundation around governance is the key to every successful cloud journey. And what is it? Cloud governance is a set of rules, practices, and reports that help you align in your cloud to your business objectives. So I know some organizations that have helped out in the past were kind of late coming to the cloud game. Their cloud environment was created by data analytics team, for example, developers using a credit card, shadow IT. So coming in and trying to establish some of that governance and rules and practices is tough coming in, but essentially, if you have that framework to work with within your organization around security, cost management, things like that, that will work in the future. So when do you need cloud governance? So when you have cloud environments, especially migrations. So, you want to make sure that you're not just doing a one for one when you're transferring your migrations on over. If you do have to do a lift and shift and move say your data center's cloud closing or some of your hardware is failing, then that might be fine. But if you're doing it in batches or a large migration, then essentially you want to definitely have some governance and set up your AWS structure, your accounts within AWS organizations, things like that. And I'll talk about that later. And then also organization transition. So, mergers, acquisitions, things like that will make it easier if you have that cloud governance set up when you're actually acquiring. Regulatory compliance and corporate standards. That's a huge one, the frameworks around that. So AWS has specific um, tools and kind of best practices around HIPAAs, SOC, things like that. And they also, certain services follow those, so you can use those in those environment. And then for developers, so basically deployment consistency, configuration enforcement, and then faster project delivery, but also without error. So, you want to make sure that your developers within, AWS are doing things properly and not going outside your governance and your security guidelines within your corporation. All right, so now I'm just going to touch upon a security overview within AWS before I start getting into some of the various areas. And kind of the security foundations, it throws into three different areas. So I'll talk a little about this, not too much. But so basically, it's a shared responsibility model. So I'll cover that a little bit later. But you can see, the responsibility for the customer and the responsibility of AWS. So there's that delineation where, you're responsible for certain things. And I'll show a slide later around, if you're using AWS managed services and where that actually changes a little bit in that. And then I'll talk a little bit about, the six principles of the well-architected framework, but I'll focus in on security primarily. And then the cloud adoption framework. So CAF for short, I'll call it later on, and we'll focus in on security in that area. So what is the shared responsibility model? So basically a lot of times, you have your own data center, you're not hosting software as a service, or you don't have, say, a third party application that you're used to. So some folks are used to owning their own data center, owning the applications, running that. So you have full control of security in your environment. So coming over to AWS, it's a little bit of a change for customers and trying to get used to like, okay, so where's this AWS region located? Each region has availability zone, which is essentially a data center in an area, and then essentially from there you have various other subsets of that for redundancy. And you can see here's the higher level. So we had the slide there earlier. So you can see that AWS takes over responsibility for a lot of those foundation services that are there. Like to say the compute storage database and low level networking. But the blue side, you see operating system network and firewall configuration. Yes, you do have control over your virtual private clouds, the VPCs, your operating systems, whether or not you spin up certain EC2 instances of Linux host or Windows host, firewall configuration within security groups, or if you're using maybe um, AWS network firewall, if you want to have segmentation there, and I'll show you diagrams around that, and you can see the encryption and traffic protection around that. And then this slide shows you, around, like I talked earlier, around the infrastructure services, the container services, and the abstracted services. So you see here that the red goes up farther to the right because those are Amazon or AWS managed services. So you see S3 KMS, which is key management services, and Amazon DynamoDB are a few of those Amazon managed services. So essentially, you are only responsible for the customer data and the client side data encryption. Whereas if you go look to the left-hand side to RDS, you'll see that you're responsible for a little bit more around that side of things. So you're responsible for a little bit more protection. And then the EC2, you can see you're responsible for a lot more on that side, giving you more control over your security. So some of the time, some folks like to use AWS managed services more because there's less security to worry about, but that doesn't take you out of the equation. You're still responsible for maintaining that, especially the customer data and the sensitivity of the data that resides on those managed services that you're using. Okay, so let's talk about the pillars. So I'm just going to cover these really quick. Like I said, there were six earlier. Sustainability is a brand new that was added a couple different years ago. And the pillars are reliability, security, performance efficiency, operational excellence, cost optimization. And we're going to focus today on security, those principles that are going to kind of add into, those best practices that we can follow. So what is a well-architected framework? It's basically consists of those six pillars. They're basically design principles. So a lot of those questions, are come backed by best practices. So over the years, I'm trying to remember what year. I think it was like 2014 or 2015 when I started early using AWS. We offered a service as a solutions architect that was a well-architected framework, but we had a spreadsheet with various questions in the various areas. There was only five pillars at that time. Six was added later on. But we would go in, ask the customers questions. It wasn't you can automate it now, but it wasn't a service that was available within AWS. So that gradually changed. Started having other lenses for the well-architected framework around industries or various services. So that's kind of evolved over the years to be better. But essentially, it's a questionnaire to kind of fill out. There is some automation that you can do. I'm not going to talk about that today, but I'll probably follow up maybe with a blog post around some automation you can use within your environment around security for the well architected review using Prowler, which is an open source scanner of AWS environments. And then just a little bit about the design principles. So these design principles, I'm going to be covering each of these during my presentation. So we'll talk about the identity foundation, having that solid foundation, traceability. So you want to make sure that in your environment, whether it's the cloud trails of traceability, because those are the commands that are being fed. So even if you're using the AWS console or the GUI, those commands for, say, spinning up an RDS server or basically an EC2 instance, those will be tracked and you'll know who's doing what within your environment. So you want to make sure that the traceability is there. By default, CloudTrail is enabled, but you want to make sure that the retention, it's only going to be kept for a short period of time. So you want to make sure that it's collected in for a longer period of time, depending on your logging requirements. And then applying security at all the various layers, automation around those security best practices, So this one's tough because a lot of folks, it might be tough to automate everything in the beginning, but what you can do is start off small. So take certain areas that you might feel comfortable in, look at some automation around. So one customer, what I did was they had AWS config. They wanted to automate based on a check with AWS config if something wasn't configured. We started off small by like sending off an email alert and then maybe turn it if the person didn't respond or fix that later on would actually go ahead and change the setting on that specific service that was in violation of the control policy. So you can start off there, and once you feel more and more comfortable, then you can work in more automation. Next one is protect data in transit and at rest. So essentially, what we want to do is basically encrypt everything. You might as well. I think one of the speeches is encrypt all is Werner Vogel's at AWS says is basically, you want to make sure your data is encrypted. You own the keys. Also making sure that it's TLS or SSL for the secure communication, whether or not it's public or private. And then basically the second one's kind of funny, keep people away from data. Yeah, you want to make sure that data is properly segmented, who has the right access to that data. And then prepare for security events, whether it be incident response or just knowing in your environment whether, it is a security event, you've defined those quite well in your alerting system. So the next one, part of the speed for the essentials is basically cast perspectives. So you can see here, it's basically just it helps organizations about adoption and transforming the way the work around cloud. So, it's good to have a cloud foundation. So a lot of times coming into an organization that's starting off, I recommend forming a CCOE or critical center of excellence or cloud center of excellence for organizations. Leading that team, it could be kind of a tired team initially, but having a group, not just technical folks, but also business leaders or even finance, because they will get involved in cost, because a lot of those changes will be evident when your finance team gets a bill and says, "Why is this? I thought, how come it's a lot different than your normal software purchasing and hardware purchasing, because it's actually a OpEx rather than CapEx." Okay, so let's go to the next one here and talk about the security perspective. So these are the areas I'm going to focus in today. I'm going to talk about identity and access management, kind of best practices, a little about data protection. I'll talk about detective control and infrastructure protection or infrastructure security. And then basically aligning that um, with the framework, essentially, then you can actually assure that you're maintaining visibility control, you're validating your systems and services within AWS, and then and more importantly, identity and access management, you're managing your identities and permissions at scale. So you have a subset of IAM, say, policies, or even more. I'm not going to talk about roles, but essentially using roles across your organization and delving out proper security permissions within those AWS environments, whether it be development accounts, staging accounts, or production accounts. And then this slide just shows you, oh my God, there's so many different services in AWS's account. So yeah, there are is. So basically, when I first started, there wasn't as many services. So it is a little overwhelming looking at the UI and looking at all the various different AWS security services that are available around those areas. Not saying you need to know all of them, but those are available to you. Some of them are maybe just one-offs. You might not need it. So essentially, AWS Artifact, that's more for um, adaptation, documents around security and compliance within AWS that you can show your auditors or show your within your organization those reports. All right, so let's get started with security foundations, and this is just you know over the years, kind of what's been building cloud environments. So account process is error prone, creating a new account. I want to make sure that everything's defined and not proper. So that's one of the big questions, especially if you're going to be using multiple accounts. Like say you have multiple dev groups or even just like sandbox accounts. So within an organization, you might have sandbox accounts that, users can use for testing, but you want to make sure that you're giving them the right permission to only launch certain services or within regions, things like that. Hard to scale the environment, mainly configuring accounts. I'm hitting service limits. So, what are service limits? Service limits, I'll just give you a brief overview for some folks, are kind of limits or things that are set aside on AWS accounts by default. So when you first create an account, it is set with limits. So for example, one is that I know off the top of my head is the max number of VPCs in an account is five, but you can actually increase those limits with AWS service quotas or quotas. So you can automatically have those every time you create an account, create those requests and have a default baseline for service limits, especially if you know where you're going to use AWS services or certain things, and you're going to hit those anytime that you try to launch any more of that. And then visibility into the resources and applications within AWS. So first and foremost, so basically, you know, it's a little bit different than other cloud providers, but essentially within AWS, you want to think as accounts as building blocks. So if you need an account, it's pretty easy to create accounts and link them to an organization and it scales across accounts. So you kind of want to limit the blast radius. So what you want to do is create an account. So usually you'll start out with your management account or your main one, and that management account is not readily accessible, but only by the fan. The billing goes there, maybe the main not the security folks, but maybe the main cloud custodians of the account will have access to that. You don't want to do too much in your management account. It's kind of the top level where all the permissions are done. And I'll talk a little bit about a service called Cloud Control Tower later and how you can use Control Tower to, create these accounts and building blocks. And you can see that within each account has its own compute, networking, content delivery, storage, and all the various services that apply to those. And then, so with this next one is you want to separate workloads across accounts. So you don't want to kind of create one AWS account and then have everything in that account. So let's just say if I'm getting started and, I want to start, I got my own account. I've been doing a lot of different things in it. It's kind of been a dev environment or a sandbox. Oh, I want to go ahead and, well, let's just use this same account for something production or open this up to a third party, as an application provider. Usually you don't want to be doing that. So it's best practice kind of to separate those workloads and kind of have accounts. So you can see here, like I talked about, AWS organization, the management account is the main one where you have the organizations, the control tower. I'll talk a little bit, and then single sign-on, or actually today it's called identity. Account management, I believe. It's changed its title. And then you have log archive accounts, specifically CloudTrails archives, things are going there. And you can see the workloads for development and production. And then there's an operations account for specific things. Recommended OU structure. So it's all up to you. So a lot of times coming in, if a customer's unsure about how they want to do it, I go over different scenarios about the product. So, if you're an organization that's going to be using primarily for IT related things, then that's a different foundational OUs and additional OUs. But if you're say this is a software as a service company that you're starting out and you want to have a organizational OU structure, then we'll have definite parameters or guidelines around that. But this is essentially how you kind of want to have it set up as an OU structure and it's best practice kind of to have this segmented out not having sandbox accounts talk to Certain other areas like pre-prod or production, those are specifically isolated completely from there. So also, you might want to block certain other things in those AWS services that could be launched in those sandbox accounts. Next one is multi-account strategy. So separation of duty. So like I said, the devs and the admins. So you can see in this one, it's kind of showing you using your software development lifecycle tooling, your code, your build. This is AWS specific software, but you could use your own. So you could essentially use GitHub. You could use Jenkins to do your builds or something else. But this area shows you that dev has its own artifacts and then also test and then prod, and you can see that the devs do not have access to test, and then you can see that admins should not have access. So basically, then production, you don't want to have any access to that. So essentially, what you're doing is kind of building a pipeline and I'm not going to be talking about that, but I could talk about that in the future is having a secure pipeline where you're doing your code check-ins, your builds, then your deployments. But essentially it's all infrastructure as code or it's being done without, any manual intervention. But you can definitely wrap around um, some some reviews around that before it's reviewed to production. Okay, so next one is a landing zone. So I'm going to talk about this a little bit further. So this helps you create those multiple accounts that are kind of intertwined in AWS, and you have access and management to that. Because if you were to go a create an AWS account, you already have one, create another one. And if you don't do have a landing zone, you don't have it in the same organization, it's hard to see that account, have control over that with service control policies. So it's kind of a starting point. Some folks say, well, what happens if I created this account a long time ago? I don't have within AWS organizations. There is kind of a way. So I have migrated folks that kind of built and kind of inherited some environments that weren't as scalable and secure. So basically created a brand net new landing zone, and then they were able to maybe migrate some of those accounts to the organization and start using those, or even just creating net new accounts and just recreating the services that were being used in the new landing zone environment. So there's a couple different ways you can approach this. You can do this with Control Tower, like I said, and then you can consider what enhancements you might need. So organizations, integrations, so customizations of Control Tower. And that's something that we do a lot of AWS Control Tower solutions on Marketplace. And then there's a landing zone accelerator that AWS Community Projects has built. And then one of the ones that's left off of there is also customizations using HashiCorp Terraform if need be. So this is an example of, one of our offerings. We have a WEI landing zone accelerator, but essentially it's just starting out. So, when you first want to have launch an account, this will be programmatic. And this could be using Terraform or Cloud Development Kit, CDK, and essentially create your environment. So essentially you'll see the management account as the OU as a root. And then under there, you'll see an infrastructure. So there's a network account for transit. So you'll see all the networking happen within that account. So you'll have your egress and ingress go through that. And then also this could be east, west, north, south, but and you don't have to do it this way, but essentially it's good to have this, especially with Transit Gateway Connect. And then the shared services account. Shared services account is kind of say it's an account that, everyone in your organization is going to use, but you still want to have some control over that. So maybe as an IT organization, it might be file shares or SharePoint or something. You might want to stick that in a shared services account with the directory services. And it doesn't need directory services, an example, if you want to tie in, but you can use Azure for Active Directory on that too. And then at the top, you can see the security aspect of the account structure. is you'll have the log archive account where everything will be logged and archived into those accounts from all those AWS accounts that you create. And then you'll have an audit account where you can take a look at things like configuring Macy if you want that, guard duty. But essentially, AWS config will be there to enforce some of those policies. And Security Hub is a tool that you can use to roll up all those different reportings from all those AWS accounts. And down below, you'll see a number four is the various workloads. And those are dependent upon initial discussions uh, with individuals in your organization, how you want the OU structure. But it's easy to create different organizational units and add them and move accounts later. Okay, so now we're going to talk about identity and access management, kind of the best practices around how to do this in your environment. So what is identity access management? So who can access what? Developers, applications can access. So you can see with the permissions defined and then what resources can be accessed in AWS. So essentially, you can have IAM policies where I am just going to be able to allow this one IAM user to access an S3 bucket to read it, only not delete or add content. So that is a possibility for those policies. So you can get very open and say, I want to provide administrator access to this account. You can do that all the way down to individually defining certain ac actions on those resources. So there's a couple different identifiers. You have the humans, developers, analysts, scientists, and anyone in your organization. And then you have your workload. So you have your CI/CD pipelines, your applications, and infrastructure are the different types of identities. And then it's, well, why use an identity provider? So basically, it centralizes user store. So that's one of the best things to do is you want to make sure you can. So with this, you could definitely utilize your existing identity provider if you have one. So whether you want to tie in like a third party like Azure Active Directory, I think I can't remember that they changed their name on that, but you can use that. You can also tie in Okta. I've done with an organization, so you can tie it into various organizations. But if you don't have a structure, you don't want to tie it in, you can use um, IAM within AWS to create those accounts and manage those accounts and passwords and kind of define password strength and other things through that. And that also reduces password fatigue, decreases the number of systems to maintain, and then ease of auditing, knowing who's accessing what and who has access to various accounts and services and resources within AWS environment. So how does IAM Identity Center work? So, you choose your identity source. Like I said, you could use Active Directory, Okta, Azure Active Directory, or other SAML providers. And then basically it syncs it and authenticates. So when you create your organization within Control Tower, then essentially you'll use a single sign-on. You choose a unique URL. If you choose that to use for GUI, or even actually when you're using it for the command line, you'll still authenticate against that URL, for example. So in our environment, I've created one for our engineering team that's called like eng or something like that. So you have a unique domain name to access that and delve out the various permissions and access to those using the single sign-on within your environment. Next one is temporary credentials. So a lot of times I'll see within companies they'll have credentials that were access keys that were created, have not been um, rotated in a long time, probably more than a year, or even, you still want to rotate those keys, but honestly, if you can use, the best way is using temporary credentials. So it's a limited lifetime expiration. You don't have to manage credentials. If you do need credentials, there's other ways, but essentially it's not the best way to do it. So that's why one of the best practices is to use temporary credentials. And then the next one is making sure you have the right access permissions to the various AWS accounts. So, like I said, you want to strict access to the management account that's created within Control Tower. You do not want everyone in your organization accessing an account. It would probably be a subset, usually a small subset of individuals that can have access to that management account, and you can decide who it can be. And then balance least privilege access with business agility. So a lot of times, it's hard coming up with the various roles. So what we do at AWS, what I've done in the past is just have various rules depending on services being used. There are managed service roles that can be used with an identity center for your environment for individuals that have the right permissions, but a lot of times they might be a little bit too permissive. And you might want to customize your own. So essentially you can kind of take some of those chain them together or just actually create your own. And then essentially you'll have those roles and permissions to define within your organization. And then requiring MFA for users with elevated access. Actually, I should say require for all accounts. So I know that initially accessing your AWS account is the best practice. Before it was definitely only, being done on the root AWS account, but now with the amount of people with number of passwords and it's difficult. So this multi-factor authentication is probably the best. Even if you don't have elevated access, it's still good to have that within your environment. And then integration with the existing identity provider is the last one. Okay, so now we're going to talk a little bit about permissions. So permissions can be looked at. There's a tool, IAM Access Analyzer, you can see on the right-hand side. Will go out, and this can actually be accessed within the security account, say if you deploy Control Tower. But if you don't deploy Control Tower and just have individual AWS accounts, you can use this to access and analyze. So you can determine whether or not you maybe have too much permission or too little. Because a lot of times, sometimes the error messages that come back about if you're trying to do something within AWS, they're kind of cryptic. I wouldn't say they're as cryptic as event log within Microsoft, but relatively sometimes some are the same. And then it can analyze your public and cross account access, so whether or not they have the right permissions. And then through this, you can have this maybe run for a little bit. It'll collect data almost like an auditing tool, and then you can maybe make modifications to those various policies to make sure that you have the right permission with the least privilege. Okay, so the part of the whole well architected and any of the foundation is infrastructure protection. So best way is creating network layers. So you definitely want to make sure that you have public, private, and segmented areas where you can access certain systems and so within here you'll see that it shows you the internet, and you're in this AWS account. You'll see Route 53 for DNS. CloudFront is public. You've set up a WAF before, which is a web application firewall between your application load balancer. And so that's in the public domain. And then the NAT gateway is egress only, and that's in the shared account. And that actually is there for external EC2 access or getting out to the internet, not coming outbound. And you can see there, I don't show security groups, but they do show NACLs and route tables. So security groups are think of it as almost like a Windows firewall or a Linux firewall where you can define rules that are layer three, TCP, UDP services on that. But NACLs are at the top level of the account, so you can define network address control lists, which are they are not uh, what do you call it? They're not they're hard to find. So if you don't have the proper logging with VPCs, you will not know what's going on or getting dropped. So those are tough, but essentially those are another layer of protection. So say if I had from the internet an IP address that was hitting my load balancer, was bypassing the WAF, or just didn't have a WAF. saw this one IP addresses with some activity, I could define a knuckle to stop that and it would drop that before you even got to the actual application load balancer if needed. So it talked about controlling traffic at various layers, and then inspection and protection is the next one. And then essentially what you want to do is so we talked about the reducing the attack surface. So you can see that there's a private NAT. So within that group, they might have access to certain other things, whereas, say the AMIs that are Amazon machine images that are part of the instances in that auto scaling group might only have access to Aurora. And then, Lambda might have access to certain other functions. So you don't want to have it widely open in your environment. And you can see there's also the using endpoints for, S3 or just endpoints for Route 53 that kind of define whether or not you can access certain resources and, having that as the endpoint as for your application. Okay, so next we're going to talk a little bit about detection in an environment. So some of the key practices, best practices are definitely service and application logging. So within your environment, whether you're using AWS services, you built your own application, or you're using a third party, you definitely want to have proper logging set up. So you can see here in the development application account that you have your various AWS services. So you have the security, the AWS config, guard duty there to look at the any nefarious activity happening in your account, CloudTrail, and then you'll see that everything is going down into the trusted advisor config in the operations account. So the operations account can look at those security alerts. Everything's getting archived in this log archive account. So, a lot of times, some folks I've seen where logging has been turned off in, say, one AWS account. Well, this case is actually all the logs are being sent to a log archive account where only a certain amount of individuals have access to that. So it will truly grab everything in your environment. Next one is basically just showing you how the log archiving with the S3 archive. So, depending on your situation, you'll definitely want to make sure that you have the right roles for that to have logs happen. And then you can see it's not just, application logs, but you can see flow logs, which is our virtual private cloud or VPC flow logs within your environment that show you what's happening in your VPC, traffic patterns and seeing what's allowed, what's denied. So you can kind of see also looking for any security issues. And this slide kind of shows you the centralized logging, just showing you at a high level from, our basically landing zone accelerator. What we've done is you have the parent security account and the security services are still there, but they basically key off and grab information from any of those other AWS accounts with the security guardrails implemented. So when you deploy cloud control tower, you can define, what policies you want to have on the account through AWS config, security hub, things like that, guard duty, and it feeds those settings on down. So, say if individuals turn that off or try to manipulate it, the parent security account in the security realm and control tower has full access to that. And you can see here it's the follow-on slide showing you a little bit more about the various services being used. Not that you have to use these, but say if you're getting started in the cloud, you want to be able to use some services getting started with the right security framework within AWS doesn't mean you have to use their tools, but if you're not familiar with the cloud, you want to have something at first and then maybe bring in a third-party vendor if you want, like Palo Alto or Splunk or someone else, you can. It's just a matter of making sure everything else is the foundation is laid properly for security. Okay, so the next one is incident response. So One of these things is you want to make sure that you automate incident response to reduce containment time. So fatigue. So a lot of times they'll see certain alerts, being defined for various things that need to happen in accounts. So you got to understand your environment, let that run for a little bit, make sure that it monitors correctly and maybe misidentifies anything that might be malicious, but essentially using security hub. So you can collect all those things initially. So when it first gets installed, you don't need to automate and detect. With security hub, you can kind of collect in a read-only mode, kind of take a look at some of that and see what's happening, but you'll be aware of it. And then essentially you can automate some of those things using Event Bridge as a service or another AWS service if you so choose. Next one we'll talk about is data protection. So data protection, so it's to keep people away from the data. So don't store, don't grant, access keys or software permissions. So I know AWS automatically looks for any GitHub or Git repos out there that actually have AWS access secret keys. So they're pretty quick about finding it. But I know that if you stick out a fake one, I've done before in the past, is stick out a faked AWS access key and shared secret key that was found minutes out there. Someone already scanned looking for those to get into account and do what they want to do for an account. And I know in the past it's happened where individuals had that unaware, created those static access keys and essentially was able to spin up large instances for crypto mining or within another region that they weren't aware of. So you definitely want to make sure that you know your environments or even blocking access to regions you're not going to be using. You definitely want to encrypt, mask those tokenize those any of those credentials. So a lot of times, some of my past jobs have been done with the finance industry or PII within healthcare. So essentially, if you want to use some of that data, you want to make sure that you encrypt it, you mask it, or you kind of tokenize it if you want to reuse it for testing, taking those proper procedures. Isolating and tooling and eliminating human access. Like I said, you can start off, right away if you're used to that, using operations code, versions control, but it might be best to kind of just get started, get used to it. Once you're used to doing infrastructure as code and kind of having the right tooling to use automation, then essentially you'll definitely want to do that in the future. Next one is a why establish a data perimeter. So you want to meet your compliance requirements, whether what industry your company is working in. You want to build that corporate boundary. So you want to make sure that sensitive data is not being passed outside your organization, like trade secrets. Plans for building, one of the companies that worked at was robotics, plans that could get out there and someone could copy um, the the parameters on building these specific robots. Provide freedom for developers to innovate and fast. So essentially, you have those proper, data perimeters intact with IAM, your encryption level, your pipelines are all set that they can innovate, but while maintaining your security posture within your environment. And then defense in depth, basically central control over any security and variance in your environment. So what is a data perimeter? So data perimeter is just the preventative guardrails in your environment. So trusted identities are accessing trusted resources. So you can see here, you got your corporate data center, you got your corporate AWS accounts, non-corporate AWS accounts, and then the rest of the internet. So you can see, Joe on the couch on this Friday afternoon, doing whatever on his side, looking at streaming TikTok or something. You basically have control over your environment and what they can access and kind of push into that. So that's why you want a data perimeter. And what makes that data perimeter? So the trusted identities, resources, and your expected network. So, say if you don't want to, you can definitely lock down specifically whether or not you can access this environment only within, say, you're still requiring as a corporate policy for your employees to VPN into a certain location, then access to your AWS account, you can definitely put in some kind of rules that you can't access this AWS account within only these IP addresses. Also using third-party providers like zero trust network access, such as AWS has a specific one, but there's other vendors out there such as Fortinet and Palo Alto. They can also do that. Okay, so best data protection best practices. So identifying the data within your workload. So definitely understanding what is in those various accounts, whether or not, even though if you're not the data custodian of that data, you want to make sure that, the sensitivity you've defined the various data, like if it's confidential, highly confidential, public information. So you want to make sure that what is data is residing in those AWS accounts and who has access to what. Basically, also implementing secure key management. So this would be with KMS. You could also use cloud HS, HSM. So, if you want to have manage all those keys and store that, you could use a third party. AWS also was a hardware, but also is a software solution that is compliant across a number of industries with FIPS too. So you could definitely use that. And then the last one, like I said earlier, encrypt everything at rest and in transit if possible. Last piece that we're going to cover, and shouldn't be too long. I'm just going to talk a little bit about application security, kind of what you can do in the cloud, but then talk at the tail end about Palo Alto Prisma cloud. So this is the traditional development journey. So, a lot of us have probably seen this, still probably maybe follow this today. You get customer requests, you get the design, develop, tests, you get a security review at the tail end. And a lot of times what happens is that it slows everything down because security is not being built into your application. So early on, that's been always the way I've done it in the past. So, even it slows a lot of things down. So having security built into the development process is the best way to go. So, the challenges are, lack of awareness for developers, engineers, resource constraints, business priorities. We need this now. We need this shipped right away. And then also security expertise. A lot of times some developers will, think, oh, this is secure this way or things like that. So even though that they might be following best practices, there's no checks against that. Not saying that you need to check everything, but it might be good to have some kind of static code analysis. I'll talk about that and how you can build that into your looking at application security. So what are the challenges? So, merging innovative architectures. So, new and the greatest technologies. So a lot of times, when you first go to the cloud, you have a three-tiered application. Certain application environment developers start using serverless, start using Kubernetes. They want to kind of go to the new path, modernization of the app. So essentially doing microservices. A lot of times, it's hard to secure that because, the individuals responsible for security in the organization, infrastructure, or security team aren't aware of those new emerging innovative architectures. So it's hard to keep grasp of that. And then you have the DevOps, driving constant change. So, a lot of times, you have sprints, 2 weeks. Within that 2 week process, you have different feature requests, things like that. But, cloud services are dynamic. So AWS, constantly releases new features, new changes. So it's hard to keep on top of that within your environment. So they might be changing something that, you thought was okay security wise, but somehow they open something up. So you want to make sure that haven't, done anything wrong with that. So security also is an afterthought. So it's, oh, we'll just do that anyways afterwards. Tail end while the security review. Oh, you can fix this later. We'll throw a web application firewall. Oh, the firewall should block that. Oh, we shouldn't be concerned about that. So it's always an afterthought. And then why is AppSec important? So basically increase velocity. So essentially you want to maintain that security bar for, within application security, but you also want to make basically increase the speed of getting features into the hands of customers. So you want to make sure that, you're following best practices, and then also within security, but also just trying to get that so addressing issues early. So basically shifting left, reducing the cost of delivery while reducing risk, and then effectiveness, so operational efficiency. So essentially, it's reduced overhead. So you're not sitting there reviewing, the code, because a lot of times the security review after the application has been done and changes for all those iterations take a little while to do, and then having individuals fix that. So now it's kind of built into that. So this will talk a little bit about. I won't go detail into every single area, but you want to start off building security into your application. So essentially, you want top level, you got the author, source, build, test, and deploy. You want to make sure you have the right requirements and design. So essentially, a lot of times what you'll want to do is before you even build an application, whether it might be a small one or whatever, but you want to do threat modeling on that. I'm not really going to go into threat modeling today, but it's definitely I'll post a link about that because I've done that for a while in my career. Pre-commit hooks, IDE level checks, and then just secure code practices that you've defined in your organization, using third-party tools that you security tools. And I'll talk a little bit about how you can use Prisma Cloud Access for that. Source, you have static application security tests, SAST. You also have the additional SAST security scanners, but the best one I like is kind of that testing phase. So during the build process or even the test, the dynamic application security testing. Because a lot of times you want to make sure that you're up to date and it's just not specifically on the security of the code. I know third-party products will test. A lot of people use open source in their applications. So you want to make sure you have all those vulnerabilities, CVEs, fixed, whether it be, from a third party piece that you're building your application or even open source, and then just continuous monitoring through that pipeline. Okay, so now we're just going to get into a little bit about Prisma Cloud. Basically, it does a lot of different things, but today we're just going to talk a little bit about the high level overview and then talk a little bit about what you can do with cloud security, cloud code security, and kind of security posture management. It also protects your workload and then identity security. So let's go ahead and take a look at the cloud code security. So basically what you can do is use this tool within your environment to fit this into any of your, policy as code. So you can, incorporate this into your IDEs that you have, whether or not you're using Visual Source Studio, another platform to build your software, and essentially will detect and back this. So you can have those hooks in there. So it covers policies from Terraform, Kubernetes, CloudFormation, Azure Resource Manager, which is ARM, and a lot of others. So, it's great. One of the things that I'm not quite sure if I'll do a workshop later is basically building in, security tools from Prisma. So they Palo Alto acquired Checkoff, and they're building it in, but essentially you can use Checkoff to look at some of the code, to do some static code analysis around your area. So you can kind of build that into to scan your code frameworks. Next one is kind of around the workload protection. So you can see here it's securing the host, containers, serverless functions. So that's one of the nice things about this tool is you can use it to do containers and serverless, which are, serverless is hard to keep track of environment. Serverless, you spin it up, it runs your function and then terminates. So essentially, you want to make sure that you know what's happening in your environment. So basically, it could be agent-based protection, agentless, and gets an idea of what's happening. You can also generate issue managements to your third-party tools, and then integrated, application API security protection. So, there's all kinds of different native checks that you can configure in Prisma. Next one is infrastructure entitlement management to deliver least privilege permissions. So this will kind of give you ability to dive deeper a little bit more. So say if you have, multi-cloud organization, so you want to tie in, your Azure environment, your GCP environment, so you can kind of take a look at this under one umbrella rather than, if it's AWS specific, it's hard. So I got to go into that tool. I got to go into another one for Azure or, so it makes it kind of that I don't like using the one um, pane of glass, but essentially it kind of provides you the ability to look at some of those policies and gives you an idea about right sizing those least privileged access to those environments.